Welcome back to our mathematics series. Today we'll be looking at running
Run.
through the lens of mathematics.
Yeah, running might seem pretty simple, just putting one foot in front of the other, but
Right?
there's a surprising amount of math and physics happening with every stride.
Yeah, we've got some fascinating research and articles to look at today.
Yeah.
We'll be covering everything from basic physics to advanced mathematical models.
Definitely.
Have you ever wondered how scientists can predict world records?
Mm-hmm.
Or why some runners just seem effortlessly fast?
It's a good question.
Well, we're going to find out.
Let's do it.
So let's start with the fundamentals.
Okay.
What are the core physics concepts at play when you run?
So one of the most basic but really revealing ideas is that when you run, your center of mass doesn't move in a straight line.
Oh, really?
It follows like a parabolic arc.
A parabola?
Yeah.
Like a ball when you throw it.
Exactly.
Okay.
With each stride, your center of mass rises and then falls as you land. For runners, this means the key to efficient running is minimizing the height of that arc.
So the less up and down movement, the less energy you waste.
Exactly.
So it's all about smooth gliding strides.
Yeah.
Rather than bouncing up and down.
Yes.
I could see how that would make a difference in how you run.
Huge difference.
So where does ground reaction force fit into this?
That's that pushback you feel from the ground with every step.
Okay.
It propels you forward, and it's directly tied to your acceleration,
Okay.
thanks to Newton's laws of motion.
Makes sense.
The harder you push, the faster you accelerate.
So physics gives us this basic understanding of the forces involved.
Right.
But I know there are also mathematical models that can get incredibly precise,
Yes.
even predicting world record times.
It's amazing.
So how does that work?
Well, A.V. Hill was one of the pioneers in this field.
Okay.
He was a Nobel Prize-winning physiologist.
Wow.
His model was one of the first to describe the relationship between a runner's speed and their energy use.
Interesting.
It wasn't super complex, but it laid the groundwork for more sophisticated models later on.
And one of those later models was developed by Joseph B. Keller, right?
Yes, Joseph B. Keller. He was a great mathematician.
Yeah, I've heard his name a lot in running circles.
For sure.
What did he do?
Well, he approached running as an optimal control problem.
Okay.
Imagine trying to find the absolute best path between 2 points.
Okay.
Considering terrain and speed limits, that's what optimal control problems are all about.
So he used math to figure out the most efficient way to run a certain distance.
Exactly. His model revealed 2 distinct strategies.
Okay.
One for short sprints and another for longer distances.
That makes sense. I'd imagine those would be pretty different approaches.
Very different.
So let's start with sprints.
Sure.
How does his model explain what's happening in, say, a 100-meter dash?
So his model describes a sprinter's velocity over time, taking into account things like the maximum force they can generate
Okay.
and the resistance they face.
Like air resistance.
Exactly. And what's interesting is that the model shows that a sprinter's speed increases rapidly at the beginning of the race and then gradually approaches a maximum value.
So in a sprint, it's all about that explosive start.
Yes, get to top speed as quickly as possible.
But longer races are different.
For sure.
How does Keller's model apply there?
Well, for longer distances, it suggests 3 distinct phases:
Okay.
acceleration, cruising, and deceleration.
I'm picturing a graph in my mind.
Yeah.
Walk me through how those phases play out.
So the acceleration phase is similar to a sprint. You're increasing your speed rapidly.
Okay.
Then you transition to a cruising phase.
Mm-hmm.
And this is where it gets interesting.
Okay.
The model suggests maintaining a pretty constant speed for most of the race.
Really?
And then there's a slight deceleration as you approach the finish line.
So for a long race, I should be aiming for a steady pace,
Pretty much.
not speeding up and slowing down.
Yeah, it might feel counterintuitive.
Yeah, it does.
But mathematically, that's the most efficient way to use your energy.
Now, of course, we're dealing with a model here.
Of course.
In the real world, there's another crucial element we need to think about.
Yeah.
Fatigue.
Big one.
Even the best runners in the world don't maintain a perfectly constant speed in marathons.
Right.
So how does fatigue fit into these mathematical models of running?
It adds another layer of complexity.
Right.
As you get tired, your force production and efficiency go down.
Right.
Some models try to incorporate this by adding terms that represent the energy lost due to fatigue.
So they're trying to capture the fact that your energy reserves deplete over time.
Exactly, and it makes it harder to maintain that ideal constant speed.
This is getting pretty complex.
It is.
But before we get too bogged down in equations,
Sure.
I want to bring it back to our listeners.
Okay.
How can understanding this math actually help someone become a better runner?
That's a great question.
Yeah.
So while we won't be crunching numbers on our runs,
Right.
having this basic understanding of the physics and math can help you make smarter choices.
About your training.
Yes, and your technique.
So what's the first takeaway you'd give a runner based on all of this?
I would say remember that parabolic arc of your center of mass.
Okay.
Minimizing that vertical movement, that's key.
You're saying focus on smooth gliding strides,
Exactly.
rather than wasting energy on bouncing up and down.
Yes, especially over longer distances.
I can definitely see how that would make a difference.
For sure. Yeah. And while you might not be able to keep a perfectly constant speed, especially as fatigue sets in,
Right.
the principle still holds true. Finding a sustainable pace that balances speed and energy conservation is key for any runner.
Makes a lot of sense. If you go out too fast, you're going to burn out quickly.
Exactly.
You'll probably end up with a slower overall time.
Yeah.
So it's all about finding that sweet spot.
Mm-hmm.
Now, we can't talk about running these days without mentioning all the technology that's become available to runners,
Right.
especially things like running power meters.
Yes.
From companies like Stride and RunScribe. Are these gadgets going to, revolutionize the sport by taking the guesswork out of training?
They certainly hold a lot of promise.
Okay.
These power meters use a combination of sensors, including accelerometers, to estimate a runner's power output in real time. It's a fascinating development, but there's still debate about how accurate they are.
I've heard there are some limitations with these power meters.
For sure.
What are some of the things they might not be capturing accurately?
One of the main criticisms is they struggle to measure the energy a runner gets back from what's called elastic recoil.
Elastic recoil.
Yeah, think of it like a spring. Your tendons and muscles store energy when they stretch and then release that energy to help propel you forward.
So like a little boost of free energy with each stride.
Exactly. And current power meters don't do a great job of quantifying this energy return.
Okay.
So they might be underestimating a runner's true power output.
Interesting.
They also don't fully account for internal work, which is the energy needed to just move your limbs.
I remember reading a research paper about this.
Uh-huh.
It argued that focusing solely on external work, like the force used to overcome things like gravity and air resistance, could lead to an incomplete picture of a runner's energy expenditure,
Right.
especially at faster speeds.
Yes.
It highlighted that failing to consider factors like internal work and elastic recoil could result in underestimating the actual workload,
Yes.
particularly for runners who maintain a higher pace.
That's a really important point. If you're not accounting for these internal factors,
Right.
you're missing a big piece of the energy puzzle.
Yeah.
And that could impact how runners train and evaluate their performance.
So while power meters provide valuable data,
Yeah,
they shouldn't be taken as like the absolute truth.
for sure.
What are some of the other metrics runners might see on these devices? And what should they keep in mind when interpreting them?
So you might come across metrics like running effectiveness or leg spring stiffness.
Okay.
Running effectiveness tries to quantify how well a runner converts power into speed.
Uh-huh.
In simple terms, it's a measure of how much speed you're getting for a given power output.
Okay.
The idea is that a more effective runner will go faster while using less energy.
That sounds like a useful metric.
It is.
But I imagine there's nuance to how it's calculated and what factors influence it.
Definitely.
What about leg spring stiffness?
That relates to how much your tendons and muscles behave like a spring during your stride.
Okay.
A stiffer spring can mean a more efficient stride, but there's no one-size-fits-all answer when it comes to the optimal level of stiffness.
Right.
It varies depending on the person and what kind of running they're doing.
It seems like we're still in the early stages of understanding how to apply all of these metrics and technology
They are.
to actually improve running performance.
Yes.
What are some of the big questions that researchers are still trying to answer?
Well, one of the biggest mysteries is why some runners are so much more efficient than others.
Yeah.
We see this, for example, with East African runners who've dominated long-distance events for decades.
Right.
Is it their genetics, training methods, or a combo of factors? We're still trying to figure that out.
It's a question that has fascinated scientists and coaches for a long time.
It has.
There's also a lot of debate about running form and foot strike patterns.
Mm-hmm.
Does heel striking really cause more injuries?
Good question.
Is there an ideal stride length for everyone?
These are all important questions, and the answers aren't always clear-cut.
Yeah.
Every runner has their own biomechanics.
Right.
So what works for one person might not work for another.
Makes sense.
The search for the perfect running form continues, but as we gather more data and improve our understanding of biomechanics, we'll be able to offer more personalized advice on technique and injury prevention.
This all makes me think back to what we were discussing earlier
Yeah.
about internal and external work in running.
Mm-hmm.
Is it possible that focusing too much on external metrics,
Okay.
like those provided by power meters,
Right.
might cause us to overlook the importance of what's happening inside the body?
That's a great point. It highlights the need for a holistic approach to running.
Okay.
We can't just rely on external data.
Right.
We need to listen to our bodies, pay attention to how we feel, and consider the mental side of running, too.
It's not just about the numbers. It's about the whole experience of running.
Exactly. There's a growing understanding of how important the mental game is.
Okay.
Things like grit determination, being able to push through discomfort,
Right.
can make a huge difference in performance.
Makes sense.
And while some people seem naturally mentally tough,
Yeah.
there's evidence that these skills can be trained.
So it's not just about building physical strength and endurance,
No.
but mental resilience as well.
Absolutely. Incorporating practices like mindfulness, visualization, goal setting
Okay.
can help runners of all levels improve and overcome those mental barriers.
Sounds like the future of running will involve this fascinating mix of data technology and the human element.
It will continue to gather more data, refine our understanding of biomechanics, and develop new technologies
Right.
to help runners reach their goals. But at the end of the day, running is a deeply personal experience.
It's about connecting with your body and pushing your limits and experiencing the joy of movement.
I couldn't agree more.
Well, I think we've covered so much in this deep dive into the mathematics of running.
We have.
We started with those fundamental physics principles, explored those fascinating mathematical models, and even talked about the promises and limitations of running power meters.
It's been a great discussion.
It has. So as we wrap up, what's the key takeaway you'd like listeners to remember when they head out for their next run?
I'd say remember that every stride is a testament to this incredible interplay of forces and energy. Pay attention to your form, find a pace you can sustain, and don't be afraid to experiment.
And most importantly, listen to your body and enjoy the experience.
Absolutely.
It's been a pleasure diving deep into the world of running mathematics with you.
Likewise.
And to our listeners, keep running, keep exploring, and we'll catch you on our next deep dive into the fascinating world of mathematics.